Hi, and welcome back. So in this video, we're going to talk about something that you'll probably see maybe in the first week of a chemistry class. And what we're going to be talking about are intensive and extensive properties. So I'm actually going to go ahead and write this down. So intensive, and I'll switch colors, and extensive. So draw a better X, extensive properties. And essentially, what intensive and extensive properties are, and I'm actually going to start by, I guess, defining what extensive properties are. Extensive properties are things that you can measure, or properties that you can measure about, you could say, a given system or a given, a given amount of stuff. They're things that you can measure about a given amount of stuff that directly depend on how much stuff is there. Now you might that's kind of maybe might sound a little bit mathy, but essentially the intuitive definition of an extensive property is that it's a measurement that's going to depend on the amount of stuff that you measure. So depends on the amount. So it depends on the amount, I'll say, of stuff that you measure. So you might kind of wonder, well, what would be an extensive property? Well, mass would be an extensive property. And, similar, we'll definitely talk about, I forget if I've defined yet how mass is different than weight, but mass is mass is going to be an extensive property. Mass, one brick has a different mass than 20 bricks. So the number of the amount of bricks that we would have if we were determining the mass of bricks directly depends on how many we have, on the amount of stuff that we have there. If we were figuring out what was the mass of a whole bunch of concrete mix, say something like that, or else even a whole bunch of concrete itself, the amount that we have directly the measurement that we make will directly depend on the amount of stuff that it is that we're trying to measure. So that's an extensive property. How about what else? How about length would be an extensive property too, right? So if I have, if we were trying to figure out if we were trying to figure out, the length of one football field, well, the length of one football field is different than the length of two football fields, right? And that might seem, probably does seem fairly obvious to you, but the length of something, the distance that you would measure, is going to directly depend on the amount of stuff, the amount of things that you're measuring. What's another extensive property you can maybe think of? Well, this is directly tied. It's sort of directly tied to mass, but it's not a lot of people get mass confused with weight, but mass and weight are not the same thing. But also weight. Weight would be an extensive property. If I weigh, if I figure out the weight of 2 cinder blocks, that's different than the weight of 12 cinder blocks, right? So it directly depends on the amount of stuff. So now, based on that, what do you think intensive properties are? Well, intensive properties are going to be those properties that do not depend on the amount of stuff. And let's think of, maybe this, I guess we'll start with at least one example that you might have sort of an intuitive feel for. Let's start with speed. And we can say if two cars are going are traveling at 60 miles an hour, or say that if a car is traveling at 60 miles an hour, it doesn't matter if a car is traveling that fast or a truck is traveling that fast or a bicycle is traveling that fast, the speed is the speed. Similarly, we could also say, if we're trying to figure out the speed of a car, if we're trying to figure out the speed of a car and we figure out, okay, based on how fast this car went over, over this one foot, over how fast a car traveled in, how long it took a car to go 1 foot of distance. We figured out that the speed was going to be, based on the measurements we took, we figured out that the speed was going to be, 60 miles per hour. And then similarly, we measured the speed over 1 mile. And we also found that the car had, I guess, a consistent speed over that 1 mile that it was traveling, that the speed over that distance was also 60 miles per hour. So if, and you could say we had a constant speed does, figuring out the speed of let's just say a car, it doesn't necessarily matter how much distance we measure or how much time we measure. So, if we said that 1 mile, if, we covered 1 mile in 1 minute, then therefore we would cover, I guess you would cover, 1 foot in 1/5280th of 1 minute. But anyway, I don't want to confuse you too much. But essentially, I just want you to see that if we're just trying to figure out the speed of a car, that it doesn't necessarily depend on the amount of, I guess, distance or time that we would measure. Just so long as we keep our units correct, we can still pretty much figure out the speed. It doesn't depend, I guess, on the amount of time we measure, the amount of distance we measure. Another property, and this is sort of, hopefully this isn't a new concept for you, but if it is, it's, I guess we'll cover it right now, is density. Density. And I know sort of the classic line, and I think my chemistry teacher back in high school asked me this, but he said, which weighs more, a pound of feathers or a pound of bricks? And you can probably say that they both weigh the same. It's just that their density is different. Density, the intuitive definition of density is essentially the amount of stuff that occupies a certain space. So I'll just write that down. The amount of, I'll just say stuff in a certain space. Or we could also say the amount of stuff per a certain space. And that type of terminology would directly lead you to how we would represent density, which density is going to be some unit of mass divided by some unit of volume. And probably, I remember, I think my first lab in my chemistry class, and I'll just write D for density is equal to mass divided by volume. My first lab in my chemistry class was, we took a bunch of pennies, and if you, I think later on in the playlist I do a whole bunch of examples where we start talking a lot about pennies. But what we did in my chemistry class was we took a couple of pennies, or we took I think it was a whole bunch of pennies, and that's my drawing of a penny right now. And what we did was we dunked that penny into water. So I'll just say that this is a little glass of water that I had. Glass of water. And if we said, okay, so a penny, now I've got this fresh in my mind, the mass of a penny it's roughly 2.5 grams. And say that, I can't exactly remember how much water a penny would have displaced, but hopefully you've seen this experiment before, where if we had a given container of water, so if we have say that's our container of water, and it's at, and I'll actually draw the container around it. So say that this is our container right here, and that's without a penny. What we're going to do is we're going to dunk a penny into that water. So dunk a penny in, like that. And then the water level goes up a little bit, right? So if you can see, I didn't draw it that big, but there's a little bit of a gap. There's a little bit of a gap in between these two water levels. That's pretty much the volume that is occupied by this penny. And let's just say I'm completely making up numbers here, but let's just say when I did this experiment with 1 penny, let's say, so we know the mass of a penny is about 2.5 grams. And let's just say, for sake of experiment or for sake of example, that it displaced, I don't know, let's say it displaced, 2 milliliters. Let's say it displaced 2.0 milliliters. So now, essentially, I've got the density of my penny, and I can clean up this fraction a little bit, but essentially I've got the density. I've got the amount of stuff, so the mass of the penny, divided by how much space or the volume that penny takes up, pretty much. And we got that by displacing water. So we figured out the density, or we could say the penny is made out of copper, so we could say it's the density of copper. Now let me ask you this. I did this with 1 penny, so 1 penny weighs about 2.5 grams. Let's say I actually did the same experiment, except instead of just having 1 penny, I actually took, let's say, 5 pennies. I took 5 pennies and I dunked them into water. And then I measured the change of how much the water level went up, and figured out the volume that was going to be occupied by these pennies. And I'll actually try to make up numbers that are going to be, I guess, similar to what you would find in an experiment if you do this, or if you did this. But if we said that, so a penny weighs 2.5 grams. So what is the mass going to be of 5 pennies? Well, the mass, it's going to be 2.5 times 5, so that's going to be 12.5, right? It's going to be 12.5 grams. And how much will the water level go up? Well, if 1 penny made the water level go up 2 milliliters, then 5 pennies are going to make the water go up. Well, what's 2 milliliters times 5 pennies? That's going to be 10. It's going to be 10 milliliters, right? So let's say, and you can probably see where this is going, but I'll just get out my calculator and we'll take 2.5 divided by 2, and we get 1.25 for our density. And then let's take 12.5 and we're going to divide it by 10. And again, we get 1.25 for our density. So pretty much, the density of, in this particular example, and I've given you kind of notional data, and maybe in the future I'll maybe clean this video up a little bit and we can talk about exactly what you would do in an experiment like this. But pretty much what I wanted to essentially get across to you is that this measurement for density, it doesn't depend on the amount of stuff that we're measuring. It didn't matter that we were only measuring 1 penny here, and then here we measured 5 pennies. Our density really comes out to be the same regardless of the amount of stuff that we're measuring. And that is exactly what an intensive property is. It's a property that we can measure, and it does not depend on the amount of stuff. So you could say, 1 penny has got the same density as 1,000,000 pennies. If we figured out the density of 1 penny, we can say, this is, or we can, or if we figure out the density of 1 gram of copper, we can figure out, to be the same thing as the density as 50 grams of copper, say. So anyway, that is essentially the difference between intensive and extensive properties. I guess hope you found this at least somewhat useful, and I'll see you in a future video.